I am very eager, like you all over here, to hear the speaker, who is Mr. Arjun, came from Symphony AI, brings 25 years of stellar experience in the field, what we are talking as a buzzword today as AI. Let's hear from Arjun with the deeper insights, what he has over the years building upon the systems in AI. So without taking any more time, Arjun, over to you.
Can you hear me okay? Thank you. So, as Vijay was saying in his very, I would say, energizing speech right in the morning, I will try to follow with his energy levels. But good thing is that, first of all, it's a delight to be here. I'm really grateful to People Connect Kargil for inviting me here. And the timing couldn't have been better. Rains are back, and that too after a long, long hartal, right? I have been here for many years now. Never had this, I've never seen the rain gods so upset with Bangalore. But now everything is forgiven. Bangalore is back to being Bangalore. We always had the traffic. So now with rains, it just feels the similar set of challenges. So today my topic is smart manufacturing. And moment nowadays we say smart manufacturing, the word AI, data sciences, AI, ML, and everything comes together. So what I'll do the first half of the talk, and please do forgive me, I'll use some slides as cues, but we'll try to keep it conversational. And then the second half I will touch a little bit upon AI and the progress. One thing is that when we do this quick bird's eye view of how smart manufacturing or manufacturing has evolved over the last several decades, the changes have been, some changes gradual, some changes dramatic, and it's remarkable that whether it has been dramatic or gradual, humans have adapted to it like ducks to water. That's something to ponder upon. Just for a moment, just imagine life without WhatsApp. Is there anyone who doesn't use WhatsApp? Can anyone recollect how it was before WhatsApp? Yeah, so I think the people who recollect, I would applaud their memory. They have good memory. But can anyone even recollect how life was before Google Maps? Yeah, yeah. Children now, if you have children at home, sometimes they're amazed is that how did you do stuff without YouTube? So that has been the shift. So with that, what we'll do, we'll go back to some slides and we'll take a quick review of the landscape. Can you put up the slides? Okay, so we kind of introduced the topic, continued rise of smart robots. It's almost like sinister, isn't it, when you say continued rise? But we'll try to put the right positive spin on it, because whatever has been happening, it has only been happening for the good. And the Kargil video, it was very nice. Some of you saw that Gemini oil, right? And believe me, if you go to a Kargil factory, the amount of work, hard work, physical work, digital work, machine work that goes behind crushing, selecting the corn bushels, cleansing it, steaming it, crushing it, rolling it, and then finally bringing it to a refined shape, and that what brings it to our kitchen and food, it is dramatic. And just one view of the Kargil plant itself would give you an idea of how science, technology, and manufacturing have evolved over the several decades. So this, can you go back to the earlier slide? I think I jumped, yeah. So this is, I think some of you would understand this rise of the empire. Everything really began with the printing press. That really unleashed knowledge across the world. Suddenly people could get access to knowledge. Earlier it was within a certain set of people. But something more dramatic happened after that. The steam engine, the steam power was invented, and that unleashed something which had huge social and historical ramification. I am not alluding to colonialism in any way, but if you look at the picture, you'll get the context is that handloom or people would make their clothes. It would be a yearly activity during festivals. They would spin new clothes and so on and so forth. But when this steam power came in, the mass manufacturing started aggregating. production from distributed sense to concentrated mass production, fast production, rapid production came in place. And this was really probably the starting point. The Lancashire mills, of course, mills became ubiquitous. It also made its way to India much later. But the advent of mills probably is the earliest start of smart manufacturing, and with that it unleashed a lot of innovations. I mean, chemicals, you need dyes, paints, varnishes, everything that brings, not in the list that makes it into your clothes, fashion, models. So just think about the range of industries that it unfolded over the last several decades, and it continues. So that was one part, the rise of steam power, which in essence heralded smart manufacturing. Second, this is not that Tale of Two Cities. I'm sure some of you would have read that book. But the same, I wanted a picture of Bangalore, but I could not get, but you would get the essence. If you look into this, this is Piccadilly, and some of you would recognize nice horse carriages. But believe me, when a city like that is only moving around with horse carriages, it's maybe a pretty sight from a distance, but if you're around there, it's not pretty. It's horse urine. I mean, somebody who would have gone around places, let's say Chowpatty or wherever there are horses, it smells a lot. So the conditions are not hygiene. So look what smart manufacturing did. It brought in mass production assembly, and suddenly people were able to build cars. So it brought in processes, it brought in organized way of production. So this is the famous Ford car manufacturing, which is called T model. But life didn't stop there. We kept on progressing. Just a minute. This is kind of stealing my thunder a little bit, so please bear with me. How do I? Can I go back? It's one more slide. Is it more easy if I tell you to flip? Yeah. Okay, thank you. Sorry about that. So we kind of got the story in advance, so think of it like a trailer. So once mass production assembly came in, the cars became suddenly affordable, and within 20 years the entire scenario changed from a very non-hygienic place where people dreaded to go out in the streets of London. Suddenly the European streets became a place of attraction. People who drive in cars, they would wear good dresses. So now do you see the all the things falling in place? Clothes, affordable clothes, designer clothes. Now you suddenly have cars that don't make you dirty. You have petrol, ICE cars that would take you from place to place. So suddenly there is a demand for steel. So now steel started getting organized. Now as people started moving out, and we just heard about the Cargill company, illustrious record over 150 years, that started moving into next levels, right? People going out means people getting attracted to spend time on their hobbies, eating out, dining out, more demand for oil, kitchens, restaurants. So suddenly the entire landscape, again, all driven by manufacturing and smart way of doing stuff. Now go to the next slide. We didn't stop there. We thought, okay, we have understood how to put a process, how to make it run better. Can we even make it more economical? Can we, because we want to produce more, unless and until we invest in tooling, automation, we probably won't be able to do that. So after World War II, especially with electricity, the power of drives, motors, and the early computers, right? The predated versions of mainframes and mini computers, automation came in. So humans were still in the loop, and believe me, if you go to many industries, this is still the norm. You have PLC, you have drives operated by human beings, but this also is gradually changing, as we'll see. So one of the incidents I was recollecting when Vijay was talking about his experience, I am a chemical engineer, so I did a lot of work around automation. And around 25 years back, when I was part of a automation project in a steel plant, and we were testing what we call now things in, we were trying to test some logic in our PLC, And the job of the PLC was to, at the appropriate time, given the impurity in the iron, I mean, we were melting iron, it's a steel making shop, you dose certain amount of oxygen so that things can, it can burn out the residual carbon and so on and so forth. So you have to balance it properly, otherwise there could be unnecessary chaotic condition. So I was doing the testing, and things were not that evolved, so we didn't. Now if you talk to somebody who is doing programming or doing testing of code, they would do in QA mode, they would do in testing mode before they finally push it to production. We didn't have the luxury, there was only this PLC, and it had to run in a large 100 steel melting ladle. So by accident, I pushed the wrong button. Again, human in the loop, making a wrong decision, and instead of taking out oxygen, it pushed more oxygen into that molten steel. So it was a heavy equipment, and suddenly, just like water flowing out of a pot, molten iron fell out. So that's another incident. Of course, I was reprimanded. I thought I would lose my job, but nothing like that happened. But they brought in process changes, they brought in safety measures, they brought in safety locks. So systems became more smart. So as human beings and machines and tools and drives, they interacted, there was the need that if you have to increase the speed of production, perhaps slowly we have to bring human beings more to a supervisory role. And that's where, if you go to the next slide, if you go to modern industry, especially in manufacturing, you would see this kind of things. It's mostly unmanned. You will still see human beings all around. But if you actually shut off the lights, the system would still work, because now it is run by machines and decision systems, which are essentially a lot more smarter. They may not be as smart as human beings who can literally think, but for a repeatable task, if you program it well enough, you'll keep on doing that again and again, just like your flight, right? I mean, of course, pilots are there to fly the plane, but once the plane takes off, pilots have no work. That's why you see them, right? I mean, if you're especially flying in a long-haul flight, the pilots come out, they go to the restroom, the air hostess, they kind of lock that aisle. You have to go to the restroom, but you really can't go because the pilots are inside. So it shows that they have nothing much to do. The entire plane is run by a computer. So nothing different happens here. So this is what we call the current state of affairs. Anything that has a repeatable mode is essentially run by robots, cobots, and you also hear the term IoT. That means IoT means you're pulling out information from the system, bringing it somewhere where some other people or set of people are looking at it and making decisions based on the information that is coming. So the operative word is robots, cobots, and IoT. Next, okay. So now this is the sequence, right? Again, the beauty of human beings is that all these things coexist. You would have still some mills, if you go especially around Mumbai, some of the mills that are still operating, you would find that it is stuck in the steam power driven drives, still functional. If you go to other industries, you will find, okay, there are still this kind of process driven. If you go to Pina, probably you see a lot of stuff operating in this mode, where people are there, their tools, their machines, like CNC machines or cutting machines and so on and so forth. But then if you go to a little bit more sophisticated industry, you will see that humans and people are building stuff. But now if you go especially to automotives or cutting edge tools, you will see this, especially if you go to a, let's say, TV industry, television industry, you will see these kind of things. So what has changed? The earlier emphasis was really the mechanization, steam power, we talked about, skills, execution, labor, those are the things. Then it progressed to, how do I understand how to operate a tool? How do I understand, how do I bring in engineering skills? How do I know how to cut iron, steel, and so on and so forth? Then as it progressed to 1950s, especially after the World War II, how do I leverage electronics, electricity, supervision, and manufacturing practices, quality control, quality management, quality assurance, just in time, all these things came in together. But now, we still are focusing on this, but now a lot more stuff has come in, especially cyber physical. Means it's not just a machine, but also the intelligence that is kind of embedded into the machine. So that is Industry 4.0. Depending on whom you talk, people are already talking about Industry 5.0, but you can get the drift. It's slowly building more and more intelligent decision making into the system. So now here we'll pause, take a shift, and we'll see how data analytics, predictive technologies are really making a mark on our industry. I just want to do a quick time check. Am I doing okay? 4 more minutes, okay. Go to next slide. Okay, so here it's a little bit of math. It's not complicated, but the reason I put this is to demystify AI. Moment you say AI, ML, it really means something very esoteric. It's really not that complicated. And I use this example to show that something that we learn in our school still applies, maybe in a little bit more involved or sophisticated manner. What is this? You have points, we do experiments, and then we draw a straight line, right? This is regression. And what kind of technology? I mean, any one of you use Google Maps today? Many of you, right? This is what happens. If you take an Uber, if you use Google Maps, they're doing nothing but some kind of regression. They know historically how things have progressed, then they overlay that information. If anybody is into stock market trading, you would still use regression. I'm not recommending it. Please do it at your own peril. But a lot of stock market forecasting and all happen in this. Classification. I mean, how many of you use DigiYatra? Some of you? Yeah, what does it do? It looks at your picture and says, okay, you are Vijay, you are Arjun, and you are Anjali, and so on and so forth, right? Again. Then another thing, how many of you use Netflix or go to Amazon or Flipkart? You buy something and next time it comes, it kind of tells you things which are related. It almost as if it understands your mind. So what is it doing? It is essentially clustering your buying behavior. Not you particularly, but your kind of people, what kind of people buy. So whenever I go in, I buy stuff for both myself and my wife. So I get very kind of mixed cues when I go in. And so, but that's understandable because I'm buying for the family. But at the heart of it, this, what I want to emphasize is that is nothing more different from y is equal to mx plus c. X is a single variable. When you have many, many variables, this equation gets complicated. If you can just click. So it takes the form of this kind of a devious monster called neural network. But if you break it into sequences, this is nothing but dividing your stuff so that each one of these tiny tots learn a little bit about your data. So once it learns, let's say it learns your facial contour, it is then able to recognize you. So if you see is all these three things, there's one thing in common. What is that? It is essentially you are minimizing distance. So next time anybody talks to you about AI and gives you a lot of, because see people who are practicing AI or computer science, they have a very bad habit. They get into jargons. Don't get into that. A doctor, he doesn't use, for a doctor, a knife is a knife. But AI people, I mean, every month they change the jargons, right? Cloud, distributed, and so on and so forth. So please ask them about first principles. So again, next slide. So now again, this, I mean, if I just look at doing a trend, this is correlation. Whenever, if somebody looks at the data in isolation, what would happen? Whenever ice cream sales rise, I get sunburn. So you might draw the wrong conclusion. That's not it. So if you click next. So really the causation, the reasoning skills become important. You just cannot put blind data analysis to your system, right? Whenever I take an umbrella, it rains. You may feel like a god, but that's not a right correlation. So this is where the reasoning skills come into play. So always remember, this is another thing, flight of bias. During World War II, a lot of planes, and this story may be known to you, a lot of planes were coming back, the bombers, B-52 bombers, they were coming back to base. And engineers observed that they did a statistical analysis, then they found that there were a lot of bullet holes. And engineers being engineers, they immediately started, okay, let's put a project, we'll stratify this, we'll bolster this. But there was a statistician who came and, wait a minute, this is known that these guys, they had bullet holes, but they still came back. Let's investigate the ones that never came back. And this is what they found. So on the top of that area, the bullet holes that came here or the shots, they never survived. So then they shifted the problem rather than bolstering this area, because they are okay, you get shot, you will still come back. They stratified this portion. And that had a huge impact on the safety of the bombers that used to go to bombing sorties. Next one. Okay, so we talked about this hideous monster. A quick one. Again, it is very simple. Let's say somebody is recording music, and this happens every day in your CDs and stuff like that. You encode that through dividing that, distributing that information into these tiny nodes. Each node by itself is not that powerful, but the combination makes it very powerful. And then you get a representation, and then when you play it back in your system, out comes beautiful music. So this kind of a representation is called an autoencoder, and it is used everywhere. Please remember, next time somebody talks to you about fancy AI, ask him about, okay, what kind of distance minimization you are doing. If somebody is just using that technique, he may or may not be able to get into first principles, and you will kind of win that mental battle with that person. Next one. So again, people talk about deep learning. Now we have got the drift. Something that uses only few nodes is a shallow model. Next, if you just press next. And somebody that uses a lot of nodes is called a deep learning. No difference. It's just math. So now once I have this thing, I can build a model to generate new content based on a trained content set, which means foundational models, large language models. Anybody heard about LLM, Llama and all? What does it? Does the same thing. So next page. So this is what I did. I went to ChatGPT in the morning today, and I asked it, can you go back? Asked it to write a 100-word article on manufacturing AI sustainability, highlight role of women. You write in the style of R.K. Narayanan, right? Okay, this is what came out. Again, you can see that huge parameters, they talk about hyper-tuning, fine-tuning, RAG and all. Don't get distracted by all these things. It's all but using things in a way that can make it do the way you want things. Next slide. So ChatGPT, very popular. Just look at how Netflix, all of us use Netflix, but to get to 1 million users, it took 3.5 years. And ChatGPT, it just took 5 days. So this is the way at which the crazy rate of technology evolution is happening. But anytime you get a new technology, just pause and think it from the first principles. You will find that you can deconstruct and make it usable to your use a lot more quickly. Next slide. So finally, I will stop here. So smart manufacturing, and it continues to evolve rapidly. Now it is a lot more interdisciplinary, right? You have chemical engineering, mechanical engineering, computers, safety, human resource, everything coming together. So there is a coalescence. So we have to be mindful of that coalescence. Out of this, so there is a network effect now. So the one way to derive value out of network effect is to understand, play with the data. That's where AI data models come in. And our ability to harness that model and make it useful to us, that will determine the way we do things. Another thing about AI is that and this is what I tell myself and my friends, is that there are ways to look at AI. I mean, I'll just use an analogy. I'll just take 1 more minute, Anjali. So people, when you say AI, oh, I don't understand this math, but don't get bogged down by that. If you are a car driver, you are not worrying about the engine. Your job is to drive that car, so be the driver. So have the same attitude when you are looking at AI. Now, if you are running a car lease company, you are not worried about driving or about the engine of the car. You just want to run operations. So that way also we should abstract our role accordingly and look at AI as a means to solve certain problems that we may be getting. But again, always base it on first principles. It is at best where AI is. It is a distance minimization problem. When you minimize distances, you suddenly can classify things, you can auto-cluster and do so on and so forth. So with that, once again, it was a pleasure to speak here. And thank you, Cargill. Thank you, People Connect.